All right, good morning, everyone. My name is Jesus Enriquez, and I am the team leader.
My name is Oli Koban, and I'm in charge of logistics.
Hi, my name is Deojo. I'm a component specialist.
My name is Deep Mystery, and I'm a software specialist.
And my name is Locko, and I'm a software specialist as well.
And our project is the Sound Compass. Now, I'm sure many of you have heard this sound before. Now, first, if you could hear that sound, you probably identified at least two things about it. First, you know it's some type of an emergency siren. Might not know what kind, but you know it's a siren. Second, you know it came from that general direction. Now, imagine being one of the 466 million people worldwide who suffer from hearing loss. You might not have even detected the sound, much less been able to pick out the content or direction from which it came.
To address these concerns, we set out to build the Sound Compass, an affordable, low-power, and compact device which will be worn on the wrist. The main functions of the Sound Compass are to detect sounds above the ambient noise level and to indicate to the user the direction and magnitude of the sound. Additionally, if the sound source came from a type of emergency siren, we're going to also identify the specific type of emergency siren to the user. We're going to be detecting the sound using a microphone array consisting of 4 MEMS microphones, which will be fed into a TNC 3.6 microcontroller. After sound analysis takes place, the microcontroller will output a vibration using a 3-volt DC motor to alert the user's attention to the device, which will then display the appropriate information on a 1.8-inch LCD display.
As for the software components of our project, we're going to be using MATLAB to pre-analyze a variety of emergency signals so that we can pick out some of the sound patterns and frequencies. For example, this is a tornado siren. This is what it looks like in the time domain. Beneath it in purple, this is the same tornado siren, but in the frequency domain. And you can see we've highlighted some of the key frequencies in that sound. So all that information would be stored on our microcontroller. We will be using an open source FFT library available through Arduino to compare our stored data to what the microphone array is detecting. We will be using our own code to compare magnitudes between the different microphones to determine the direction of the sound. So two microphones pick up a louder sound on this side, it's going to be this side. Now, through the Sound Compass, we aim to improve the quality of lives to all those people who suffer from hearing loss, especially those who suffer from total hearing loss, where alternatives are limited. So thank you.
So your goal is just for emergency signals only, or just all general sounds, then you're going to color code the different sounds?
So we will be identifying all sounds above the ambient noise level, but only direction in that point. As far as specific type of sounds, we're going to only code in emergency signals. So for example, if somebody over there drops something and it makes a loud boom, the device will pick it up and identify that direction, but you won't see any kind of details about the type of sound because it doesn't have one of our patterns.
Training data, you don't have.
The current data, right?
So for emergency signals like ambulance or weather warnings,
Right.
how are you going to color code them?
Color
How do you distinguish them for the user?
So what we have, so we're still working on collecting the data from different sirens. So what we're doing is feeding in, for example, an ambulance siren, for example. All the different frequencies and patterns of the sound, we are going to store that data on board the device. So we're going to do that beforehand. We're going to have a library that we create, and our device, the TNC microcontroller, is going to be able to identify those frequencies whenever it hears the sound. And that's what we identify. Yes, sir.
Where are these microphones and how many do you have?
So we have an array of 4 microphones. This is pretty much a mock-up of our device. We haven't built it yet, but this is what we want it to look like. There's going to be 4 microphones on the 4 corners of the device. In the middle, there's going to be an LCD display. Whenever it detects one of our analyzed sounds, we're going to have the data show up here, as well as the direction that the sound is coming from.
On that direction, let's say I'm wearing your device in my hand.
Okay?
My device detects a sound and
Mhm.
I pick it up.
Right.
What is that going to tell me?
So
Like
our goal is to have the device update in real time towards the direction, as long as the sound is constant. So let's say that it's over here.
Well,
Let
sound
me
went down.
ask you a question.
Sure.
Direction, it will tell me northeast or southwest from the direction, or it's going to just detect the let's say my device was in this position. So sound came through this. So it's going to give me the direction this side, and when I pick it up, I should look left or look back?
That's exactly right. So whenever, regardless of which orientation of the device, if the sound is coming from this side, if I hold it up this way, it's going to continue to point to the direction. We don't specify north, east, south, or west. It can be worn on left-hand side or right-hand side.
That's a pretty relative and would be confusing many times, so
All right.
I would suggest you incorporate some
Some sort of
absolute measures in
direction.
there.
So, on that point, I'm gonna just disagree because the arrow pointing that way, I know that way. I don't know north from south in this room right now. And if I'm traveling, which is really important for a person that's having hearing difficulties, I don't know north in LA at all. So I just need to know that way. So.
But as long as you keep memory, you
Yeah,
memorize.
that's what I'm saying.
There's going to
If
be a
you
point of
remember,
reference
it's
on the
fine.
device so that we know which side is the top and the bottom, but that's pretty much all we had planned for. Other than that, the arrow will be free-floating.
Have you thought of using existing handheld devices?
We looked at a few, but honestly, there's nothing, for example, the Amazon Echo, when you talk to it, it picks up a sound. But mobile devices that do this type of signal analysis, there really weren't any to use.
What about the reflection?
So reflection is a problem we've had in testing. That's something that we're working on. That's something that we are trying to test. We haven't gotten there yet, but it's possibly providing some sort of shielding around the microphones to prevent angular sound coming in to throw it off. So one thing we could test there. Other than that, we also are looking into maybe implementing a phase difference between the two microphones to better identify the direction. Right now, it's just magnitude.
I think you know Dr. Arya, right? In his lab, some folks were working on blind convolution of sound. So you might want to reach out to that lab and understand how they did that. So.
Okay. All right. Thank you.